Alright, looking at 2.3, using scatterplots to analyze data. When we're looking at scatterplots, we have to understand certain concepts. Inference. Inference is a conclusion based on reasoning and data. So we can infer information from a scatterplot, and we'll see an example of that in a minute. Dependent variable. Dependent variable is a variable that is affected by some other variable. Independent variable is a variable that affects another variable. A scatterplot helps to see a relationship between the variables. So for example, an example like this, you can see a relationship there. And then whereas this particular one, there's no relationship with those variables, and this one, it looks like there's a relationship between here. So for example, in this one, this being the independent axis, this being the dependent axis, you can see that there is a positive correlation, positive trend, positive correlation between the variables. As x increases, as the independent increases, so does the y. In this case, you have a bunch of scattered dots, so there's no relationship between these variables. In this one, you can see that there is a relationship with these variables, so as x increases, y decreases. The y values are going down. So again, as x increases, y decreases. So one more time, this would be considered a positive trend, a positive correlation. This case, there'd be no trend, no correlation, and this will be a negative trend, downward trend, negative correlation. Okay, next we're looking at outlier. An outlier is a measurement that differs significantly from the rest of the data. So for example, looking at here, we can see that there's an outlier here at this point. This point is an outlier from the rest of the trend of this data. Okay, so the outlier is the point that doesn't really follow the trend in the data. So it differs significantly from the rest of the data. Now, next part that we're looking at, just a second, is now collected data can be displayed using these methods: paper and pencil graphs, graphing calculator, and finally Excel or other graphing software. Now, when you're collecting this data and you're analyzing it, paper and pencil graphs are great, but the problem with paper and pencil is the fact that it can't be manipulated. Let's say you made a mistake, it's very, very hard to refix it, and sometimes you have to redo a graph. Graphing calculator is a great way to do it, but again, there's a lot of buttons that we have to push, a lot of buttons that we have to figure out, and finally with those buttons that we have to figure out, you have to then understand what the graph is giving you. The last one, Excel, is probably my favorite way for in terms of graphing using information to be able to graph it. Excel in particular, Excel spreadsheets or any other type of spreadsheet graphing software gives you a nice way to be able to analyze your data and allows you to manipulate it or change information if you need to, or other information has been included. So adding information or possibly fixing some information is very easily done, and it's a great way to learn how to take the collected data and give a way to represent that data. Next, now what we're going to be doing is, in this particular course, what we do is a lot of information in stats in terms of everything. So if you were to say, is there a relationship between a person's forearm length and hand span? So we need to see that relationship. So in a separate piece of paper, you might go through all of these concepts, develop an objective, hypothesis, procedure, observations, conclusion, evaluation, reflection. So the objective of the game is to calculate the person's forearm length and hand span. Hypothesis, let's say you made a hypothesis such as a person's forearm hand span will be have a relationship with the forearm length. So as a person's hand span increases, the forearm length increases, or something along those lines. Procedure, you gather everybody's forearm length using a ruler, all of those things, and then you calculate it using a chart, and then you make some conclusion. So what we did in class is we calculated all this information. So you collect the information of the hand span, of the forearm length, and what you do is you calculate it and then you draw some graphs with regards to this. What you'll notice is that there's an anomaly in this data. In particular, if we look at an example, this one over here, very small, and you'll see that it's a small hand span and a small forearm length in comparison to everybody else. So that might be one that has a significant outlier. Another one is a small hand span, and look at the forearm length for this one. Small hand span, but a giant forearm length. So again, this kind of example could be something that you can see. This information can be easily organized in a spreadsheet data or even drawing it by hand. All right, folks. Well, that's the end of the information of using Scatterplots to analyze data. Well, one more thing before we do that. Let's talk about how we draw a graph. Here's an example. All the information that we had going up was, notice here that it goes in order. Notice here that I started here at 22, and we don't put a 0 here, folks. So this is important. There's no 0 in the corner because it doesn't necessarily have to begin at 0. What you do notice is we skip a block and we start with the lowest number that we want to plot the data. Let's say 22. Then we're going to go up by ones. Every 2 blocks is 1. So 23, 24, 25, 26, 27, 28, 29, and 30. It doesn't mean we have data in all of these points. What this means is we have to go by an even scale going up. So we're going by 2s. We could go by 3s. We could go by 4s. We could go by 5s. We could even go by hundreds if we need to. Don't forget, we want to list on the side forearm and the measurement in centimeters. So along the side is forearm, the centimeters, and going up by 2s. Every 2 blocks we're going up by 1. And I only number every second one. Now, going along the horizontals. So forearm depends on hand span, meaning that the forearm length and the hand span have a relationship. Forearm depends on your hand span. Now, hand span is 17, 18, 19, 20. But notice I didn't put them all here, one after the other down here, because we want to fill up this space with all the different dots. Specifically, it goes 17, then I skip every 4 is 18, skip every 4 is 19, skip every 4 is 20, 21, 22, and 23. So notice I do not do a zigzag like some graphs tend to have a zigzag. A zigzag is no longer required. A 0 is not required here because I could change my scale to be anything that I want it to be. And what we would do is plot all those points that we just saw on the last graph. So what we're going to do is just plot those points now so we can see what those points will look like on this particular graph. Okay, so here's an example of all the points plotted here. And you will see that, again, the axes are the same, the scale that we just had, but here are the points plotted. So your graph should look very similar to this in the sense that there is no big open spaces anywhere. The dots look widespread, and that we don't see any major empty space areas. And now if you're to look at this data, you need to see where an outlier occurs. Some of you might be thinking, well, this point over here looks like an outlier. Or possibly you could be referring to this point over here. And I would say yes, you could consider either of these more of an outlier instead of these dots, which tend to be clustered around this kind of area where you would possibly draw a line of best fit if you were to consider the data. Looking at this, what kind of data do we see in this? What kind of trend? Well, we can see that there is a positive correlation or an upward trend of the data. So as the hand span goes up, so does the forearm length. All right, folks. Well, that's the end of the video. with respect to scatter plots. Have a numerical day.